Hello, everybody. This is Mr. Corzine. I told you I would finish these notes with you. Well, we never actually got them started. So um, I wanted to record these notes, and you can follow along with me and fill them out. That's a part of your assignment for this weekend. And then hopefully you can finish your assignment on the worksheet, the 2.5 worksheet. Remember, you're supposed to do numbers 1 through 29, the odds. Okay. Hopefully that won't be a challenge for you after we go through these notes. And I'm hoping that maybe some of the anxiety that you have or the frustrations you had on last night's homework will get ironed out too. So here we go. We're talking about expressions. And this expression that we have here has multiple terms. Now, terms are they're parts or chunks of the expression, and they're separated by these addition or subtraction signs. Okay, so each one of the terms in this expression is going to be, and I'll change colors here. We've got 7x, and we've got 3x, we've got 5, and we have 8. All of those are different terms. That was a pretty ugly 8, wasn't it? Those are different terms. Now, not all terms are the same. In the next row, we're talking about like terms. 7x and 3x, they are like terms. They both have a variable with them. Now, the coefficient in front of that variable is not the same, but we can combine those if we wanted to. If I erase this here and go back, I can actually take 7x and 3x, and I can combine those together. It's a positive 7x, and I have a positive 3x with it. And those combine together to make 10x. In addition, I have these two other terms. It's you might call them a regular number or something. We've got 5 and 8. 5 and 8 are constants, plain old regular numbers, and they don't have a variable with them. I can always add constants together. So I'll take a positive 5 and a positive 8. Notice how I'm circling the sign that is preceding the number. That just travels with it wherever it goes. I bring those together, and 5 plus 8 makes a positive 13. So this new expression, or simplified expression, is 10x plus 13. We go down the list here. We've covered coefficients. That's the number in front of the variable. Constants are the regular numbers. And in the end, when we combine the like terms, it makes 10x plus 13. Moving on, we want to use the distributive property to write equivalent expressions. The distributive property helps us to work with a problem where there's parentheses. We've got m plus 5 in parentheses, and according to the order of operations, we have to evaluate this part first. Well, right now we can't combine those two because m and 5 just won't go together. They're not like terms. But what I can do is, if you remember this from last year, we take and we distribute the 6 to each one of those terms, and it becomes 6m plus 30. I have multiplied each one of the terms on the inside of the parentheses by 6. So that becomes 6m plus 30. Here, I'm going to do the same thing. 2/3 gets multiplied times 6n and times 9, or I could say times negative 9. My new term, or my new expression, will say 2/3 times 6n minus 2/3 times 9. Over here on the side, I can do 2/3 times 6. I can multiply across. Before I do, I might want to simplify. 3 and 6 become 2 and 1 because they can both be divided by 3. So I end up with 4 over 1, or just 4. So now this combined makes 4, and I bring down the n. 2/3 times 9. 2/3. I'm going to go over here on the side again. Again, I can simplify by dividing both of these by 3. So I get 3 and 1. This ends up with 6/1. So now combining these two together makes 6. So I get 4n, bring down the minus sign, makes 6. 4n minus 6. Next, -4 times the difference of x and 8. So I distribute the -4 to each one of these, and I get -4x, and then I'm going to subtract a -32. But I can maybe speed things up a little bit by saying I'm going to multiply times a -8. So a -4 times a -8 makes a +32. So really, I can skip the step of having to combine these negative signs afterwards, subtracting a negative, and I can just say it's -4x plus 32. Finally, the last one, number 4, -6v gets distributed to each term on the inside, v and a +1. So -6 times v times another v is going to make -6v squared. And then a +1 times a -6v makes a -6v. And that's our answer for that one. It's simplified down to -6v minus 6v. All right, next, what we want to do is we want to identify all the different parts, refer to the different parts of our expressions correctly, and then know how to organize them. I'll just say right now that all of these separate chunks are terms. And if I could be even more specific, I'm going to erase this, and I'm going to circle them, keeping the sign with each term. That way I can move around. Whenever I move these terms around from one place to the next, they will always keep that sign, and that will help me to just keep track and make sure that I don't lose some of the meaning of the expression. So, what are the terms? Well, I've already answered that question. What are the like terms? As I look here, -10x and 8x, a +8x, those are like terms. If I wanted to combine them, I could, and that would make a -2x, because I've got +8x and a -10x. Those combined to make a -2x. I also have +8 and a -5. If I combine those together, those would make a +3. What else do I want to identify? I want to identify coefficients. My coefficients are a +8 and a -10. And my constants are a -5 and 8. If I go down here to the bottom, we know these are our different terms: 4xy, 3y, 9xy, and a -15y squared. What are my like terms? I definitely have 9xy and 4xy. Those are fine. I can combine those to make 13xy. But can I combine 3y and a -15y squared? No. These are not like terms. Y and y squared are different. They are worth something different, and so I can't combine them. If I had another like +2y squared, I could combine that, and that would make a -13y squared. But I don't have that, so that's where I'm stuck. Moving on to the next one, let's practice simplifying some of these. And the big challenge here is you have to make a decision for each one. Do I use the distributive property? Do I combine like terms? Do I do a combination of those? So you have to like work through the process, and it takes some practice. So let's try it. I would encourage you guys right now, if you're listening, following along, you should pause and see if you can evaluate these and simplify them, and then try and compare to what I do. See if you get them right. Here I've got 8 plus a negative 13x. There's nothing I can do. These are not like terms. So the only thing I can do is, instead of saying adding a negative 13x, I'm going to subtract 13x. That's as simple as it gets. Here I've got 9y plus y. And what some people fail to do or fail to recognize is that there is an imaginary 1 in front of that y. So now I've got 9 here and 1 here. Combine them to make 10y. And that's as simple as it gets. Down here at the bottom, it's a little more complicated. The first thing that we'll do is we will distribute negative 5 times 7x, negative 5 times 4y. So I get a negative 35x minus 4y. And then be careful, when I distribute and multiply times 3x minus 2y, I have to take the negative with the 10. So it's negative 10 times 3x to make a negative 30x. It's a negative 10 times a negative 2y to actually make a positive 20y. From here, I combine a negative 35x with a negative 30x, and it actually makes a negative 65x. Then I have a negative 4y and a positive 20y. Those combine together to make a positive 16y. And that is my simplified expression. And our next one, we'll just keep going as quickly as we can here. We're going to translate and simplify. You might also want to stop and pause the video here and see if you can translate it correctly. 5 times the difference of y and 2 increased by the sum of y and 11. It looks like this. 5, parentheses, the difference of y and 2, I subtract it, increased by the sum of y and 11. I can put that in parentheses too. So there's my translated expression. From there, I use my distributive property to make this 5y minus 10, and then I add y and 11. When it's all said and done, this makes 6y. Negative 10 and a positive 11, this makes plus 1. So it's 6y plus 1. In our next slide, this is where it gets a little easier. We've got a negative 18 and a negative 4/3. We want to find the multiplicative inverse. Whenever we want to divide by something, we really multiply times the inverse. Negative 18 over 1, when we flip that and find the inverse, it's negative 1 over 18. Here, we have to take an extra step. Negative 4/3, if I make this into an improper fraction, it's a negative 12 over, negative 12 plus 1 makes, 12 plus 1 makes 13 over 3, and it's a negative value. Then I flip it, so I get 3 over 13. Don't forget the negative sign. Moving on. Now I want to divide. Now we did this in our previous day's homework, but we might not have caught on exactly. Whenever you divide, you really are multiplying by the inverse. Okay? The example is, if I have 10 and I want to divide by 2, well, everybody knows that's 5. But I can also look at that as multiplication. I'll take 10 and I'm going to multiply times the inverse of 2 over 1. So I'm really multiplying 10 times 1/2. And you guys know 1/2 of 10, that's 5. It's the same type of language. We're used to doing that. We just maybe haven't thought of it as changing division into multiplication. So here, I'm going to change this problem into multiplication. It becomes 8 times the inverse of negative 4 over 11, which is negative 11 over 4. Now I'll convert this. I'll change this. I'll divide both of these by 4 to simplify them a little bit. I'm sorry, that's a 1. Now I get 44 over 1. Now this is a negative number times a positive number, so I get negative 44 over 1, which is negative 44. Here we're going to find the mean of our numbers. We want to find the sum and divide by how many numbers there are. The total number of numbers. That's an interesting way of putting it. But I'm really just adding these all together. 7 plus negative 4 plus 1 plus a negative 9 plus a negative 6. There's all kinds of different ways that you can take shortcuts and things. I've got 1, 2, 3, 4, 5 different numbers. So that means I'm going to divide by 5. I usually go through and I find all my negatives. I combine those. Those make a, what is that, negative 15, negative 19. And then I combine my positives. That's 1 and 7. That's 8. So 8 and a negative 19 makes a negative 11. So really I've got negative 11 over 5, which is really, I believe, negative 2.2, or negative 2 and 1/5. That's the mean. You find the sum and divide by how many there are. All right. So now let's do these two. These are the most important. If we stop after this one, you'll probably be okay. 90x minus 27 over negative 9. This is really, you can take each of these expressions and split them into two separate fractions. 90x minus 27 over negative 9 can really be written like this. 90x over negative 9, and then 27 over negative 9, and in between, I put my subtraction sign there. Now I can simplify this further by then doing this. What's 90 divided by negative 9? Well, that's a negative 10, and I keep the x. And I'm going to subtract 27 divided by negative 9, which is a negative 3. The last step to take is to simplify the subtracting the negative 3, so it's a negative 10x plus 3, and that's as simple as it gets. Well, once we've done that, we can start to see the pattern, and we can take some shortcuts. I can take negative 24a divided by 8, and I know that makes a negative 3a. And then I can also take 10 and divide it by 8, and I'm going to add on, well, it simplifies down to 5/4. Or, that's one way of writing it. Or I can say negative 3a plus 1.25. Okay, either one will work. Evaluate the expressions. I can let you plug those numbers in. It ends up looking like, what, 4 times 6 over 3 times a negative 8 plus 6. This becomes 24 on top. That's a negative 24 plus 6. So what is that? Negative 18. When I simplify that down, both of those can be divided by 3. It makes 8 over 6. Well, they can both be divided by 6. So that's 4 over a negative 3. And you can leave it like that, or you can do negative 1 and 1/3. Either one of those will do. Last one, find the average rate of change. The only reason they bring this up is it's apparently something is going down. It's going down 50 feet in 20 seconds. Maybe it's a bicycle. Okay, so we got the bicycle, and for some reason it is falling out of the sky. Okay, maybe it's giant watermelons, maybe it's an airplane, maybe it's a crashing helicopter, I don't know. But it's falling, so negative 50 feet over a positive 20 seconds. When you simplify that down, that's 5 over 2. You're losing 5 feet every 2 seconds. A unit rate would be for every 1 second, so you're losing 2.5 feet a second. Okay. I hope you guys have been able to make sense of this. I know after our last assignment it was a little iffy. Please, if you need to, go back over the video a couple times, rewind it, go back, do the tough stuff a couple of times, check your work, and then complete your homework assignment. It was that 2.5 worksheet. and you're doing the odds. Numbers, what was that? 1 through 29. Okay. All right. I hope you guys have a great weekend, and I'll talk to you soon.